In this video, I want to talk about Angular Builder. First of all, let's discuss why a builder and not a schematic. Well, Builder allows me to configure it per application. As we get into this, you'll understand why it's best to be able to configure it per application. The reason I chose to use a builder and not a schematic is a builder I can configure in the project where I'm using it. So in this case, I have PRB Lib, which is a new project that I'm working on, and in this project I'm going to be demonstrating how to build libraries. In here I need to update the package that's part of the library, but I don't focus on that. I'm always focused on this package, because whenever I need to upgrade a package version, I always do it here. I don't think about this. Well, when I've got these out here, I want to be able to get them updated from this. Where you have a schematic doesn't have configurations on a per project basis like you do with a builder. So a builder is what you really want to use. That is why I chose a builder and not a schematic. Now let's discuss builder architecture. The builder architecture is pretty simple. You have your source folder that contains the builder, and in the builder you've got your builders, and in here you have a builders JSON which defines all of your builders. In this case I've only got one builder right now, and that's patch lib package. I have an implementation which is going to point to my TS file here, index.ts, and I have a schema, and I have a schema JSON, and I have a description. The description should define what this builder is doing. In this case, we go into the schema and we see the properties. The properties are the options that are available. These options can be overridden in the project where you're using this. This is where a builder makes more sense than a schematic, because you can configure it, and this is where you would configure it. So you have a default configuration. So there's a default value here. These might be in different locations. I just picked this path arbitrarily. This one's usually accurate, but sometimes your base package is not in the base of the project. So it depends on how you shape your project, how you architect your project. Now let's go look at the index. In the builder, we have an index TS. So in the builder's implementation is where we point to our TS file. It's got to be index TS. If it's anything else other than index TS, you're going to need to add that in here. But by default, it's going to look for index TS. Now I'm doing a TypeScript. I can do this in JavaScript, and I have to configure my TypeScript down here in my TS config. So in my builder, I have build options. So my build options contain the options that I want the user to be able to configure. And these are options that are passed in, and then I have a builder context. The builder context gives you access to the project context that you're manipulating. So if you want to change a project, you're going to need to use your builder context. In this case here, it's defaulting to that because that's what the second parameter of create builder is using. Using the context, I'm doing a logger info out to print out a message saying that I'm patching the library, and it gives the library path. So this is the path for the package JSON in the library. Next thing is I get the actual path, and now I have a try catch here. So with a try catch, I get the information, and then if I fail, I'm going to return an object that says success false. Failure is when your builder doesn't have all the information it needs, or the configuration is incorrect. It's going to tell you here that that part of it failed. We're going to see down here that reading the project package JSON, if there's a failure there, we're going to return a success false. So now we read the file synchronously, and this is a method that's built in to the builder project. These are all up here in the imports. And normalize. This normalizes, so that takes care of if you're on a Windows or on a Mac, it'll run the same way. And then this is your options package path. So this is getting the package path, and it's UTF-8. If there's an error, it will tell you that it's unable to read the package path. This is your package path for your package.json file that's in the root of your project. Now, this is where the actual work is done. So we start here, we're looking for the version information. And when we find in the package.json content, this is the library package.json content. When we find the key that matches version, we're going to parse the package. This is the high-level package.json. We're going to take its content and get the version from that and put that into the library package. Next thing we do is we're going to go through the dependencies, and this is the dependencies that's in the library package. So we're looking at the library package dependencies, and as we find these, we look for the same package dependency in the regular package.json. Now, if we don't find it in the package.json, it will get removed from the package.json in the library package.json file. So you don't have to worry about that. It'll automatically remove it for you. This is for the peer dependencies. This is in the library package.json peer dependencies. And it's going through and it's looking at the dependencies. Never want to look at your dev dependencies. You always want to look at your dependencies, because those are what the library is going to need. And the peer dependencies, the purpose of the peer dependency is so that when you install the library into your project, these are the packages that your library expects to exist in your project. If they're not there, you're not going to be able to install the library properly. The next thing is we write it out. So we're going to write it out to the library package.json now. So we've read and parsed through both files, and we're now outputting it into the library package.json. And then we return success true, meaning everything succeeded and we don't have a failure. Now let's discuss the node package and how you use it in a builder. Package.json is what defines your node package. Your node package in your project comes out of your dist folder. So your dist folder in this case is under builder. So to create the package, what you want to do is you want to go in to a terminal and change directory into the dist builder folder. So now we're in the dist builder folder. So at this point, let me just go through the build real quick. So I would click the build, and the build is going to create the dist folder. It'll destroy it and recreate it. All right, so now I'm in my dist builder folder. I've built the package, and now I'm going to publish it. So now I'm going to publish it to my local npm repository. This is running on my machine. I have instructions in the project here on how to set this up, and it published it. All right, here's my local npm repository, and you can see I've got PRB builder. Now let's discuss how to use the builder in your other Angular projects. Now let's talk about how to use the builder that we created. So I showed you before just running it, but I just want to show you how to set it all up. So in the projects folder, so this is a library project. In other words, it's a project that has a demo. So here's under the projects. This was created with the Angular command to not create an application by default. So then I created an application, and that puts it into a projects folder. In this case, it's the demo project, and I have a library. Now, the old way of doing it, the library would actually show up under projects. So I'm changing it here because I just want to see if it works, and it does. I just want to put this under a completely different location. So in here, I have my package.json, which we see over here in this window. And in this window here is the regular package.json. This one is at the project level. Going into the architect section of the angular.json file, you want to set up another builder. So the other builders, we've got test has its own builder, which is an Angular build karma. This is the builder name, and this is the particular builder in that they're looking for. So if we look at here, so we've got it's Angular build extract i18n karma and dev server. And then if we go here and look at this one, it's also with build application. Now in here we have configurations, production and development, and we have options. So what we're doing with the patch library info is we're just using options. We have the builder and options. We don't have anything else. So under options here for the application builder, you can see that we've got several things going on here because it's quite complex. So for the patch lib info builder, we just have the builder path, and then we have pointing to, so now we're pointing to the options here. This is our library package path. So library package path, move this over so we can see better. So library package path is in the library, so lib, PRB lib, and it's right here, and that's where that's located. Now the other one is in package.json. Now I don't have one down in the demo because it's actually using this one up here. So that's how you configure patch lib package builder. I hope that helps you understand how to build that. To help you further in the repository, let me pull this back up. In the repository, I have builder MD file here, which goes into detail a lot of the pieces here on how this comes together. There's a README. It's got all the information basically where these things are. And if you want to set up I can't even say it properly. If you want to set this up, it's a free NPM repository manager that you can set up. If your company uses a repository, a private repository, I strongly suggest you use that instead of this. The ones I've used in the past are Nexus, JFrog, GCP Artifact Registry. I haven't used AWS Artifact Registry, but I'm assuming it's very similar to the others. With GCP, you have to do a lot of, either you do it or somebody else has to configure the system, but it works very nicely. And JFrog is a really good tool. JFrog has a lot of extra tools in there to scan your libraries to make sure that things are clean and safe. Nexus is the first one that I used, and it was very nice. I got used to using it, and it was just like using the public NPM repository. They're all very good. I would strongly suggest if you're working for a corporation that you use the corporate private repo. Otherwise, if you're doing it on your own, or if you just want to test it locally, even though you might have a public one, you can set up this free Verdaco. I can't even say it properly, but if you can set this one up, this is a good repository manager. Just be aware that if you do set this up, you have to have it running from now on because it's a proxy between the public NPM repository and your local one. And if you don't have it set up, you're going to see a timeout going on, and it's going to drive you nuts. So just always have it running. I have information in here on how I did this, and I will leave a link to the repository in GitHub where this is located. I hope this is helpful and beneficial. Let me know in the comments if you have any questions. Thank you.